React Unlocked, your hands-on guide to building dynamic web applications. Chapter 1, The React Revolution. Why React? Imagine you're building a truly interactive web page, not just a static document with a few links, but a dynamic dashboard, a social media feed that updates in real time, or an e-commerce site where product filters show instant results. What happens when the user clicks a button, types into a search box, or when new data arrives from a server? Parts of your page need to change, often multiple parts at once, and they need to do so smoothly and efficiently. In the early days of the web, and even today for simpler sites, developers often used vanilla JavaScript or libraries like jQuery to directly manipulate the content on the screen. They'd write code to find an element, change its text, add a class, or hide another element. This approach, while effective for small-scale changes, quickly becomes like trying to untangle a ball of spaghetti when your application grows. Keeping track of what changed, why it changed, and how it affects other parts of your interface can be a monumental challenge, leading to what developers sometimes call spaghetti code. A tangled mess that's hard to maintain and even harder to debug. This is where React comes in, ushering in what many consider a revolution in web development. In this chapter, we're going to explore what React is, why it became so popular, and how it solves some of the most frustrating problems in building sophisticated user interfaces. By the end, you'll understand why developers globally, from individuals to tech giants, have embraced React to build the interactive experiences we use every day. So, what exactly is React? At its core, React is a JavaScript library for building user interfaces. Notice the word library, not framework. This distinction is important. A framework often dictates your entire application's structure, like a pre-built house you customize. A library, on the other hand, is a tool you can use and integrate into your existing projects, like a powerful appliance you bring into your home. React focuses specifically on the view layer, the part of your application that users see and interact with. It was developed by Facebook and released to the public in 2013, quickly gaining traction for its innovative approach. The real power of React lies in three fundamental concepts: its component-based architecture, its declarative nature, and its clever use of something called the virtual DOM. First, let's talk about components. Think of building a complex web interface as assembling a machine. Instead of molding one giant piece of metal, you design individual gears, levers, and buttons that fit together. React applies this principle to your user interface. It encourages you to break down your entire web page into small, self-contained, and reusable pieces, each an independent component. For example, on a social media website, you might have a post component, which contains smaller components like an author profile component, a like button component, and a comment section component. Each component is responsible for its own look and behavior. This modular approach makes your code much more organized, easier to understand, debug, and reuse across different parts of your application, or even in entirely different projects. It's like building with Lego bricks. You can combine standard bricks in countless ways to create anything from a small car to an elaborate castle. Next is declarative UI. This is a powerful shift in how we tell computers what to display. In the older imperative approach, you'd give the computer step-by-step instructions. First, find this element. Then, remove its active class. After that, add an inactive class to it. Finally, change its text to loading. You're telling the computer how to perform the change. React takes a declarative approach. Instead, you declare what you want the UI to look like at any given point in time, based on your application's data or state. You say, when the data is loading, I want the button to say loading and be disabled. Otherwise, I want it to say submit. You state the desired outcome, and React figures out the most efficient way to achieve that outcome. It manages all the intricate steps of updating the actual web page for you. This makes your code much easier to reason about, as you're primarily concerned with the what rather than the tedious how. It's like ordering food at a restaurant. You declare what you want. I'd like the pasta, please, and the kitchen, React, takes care of all the complex steps of preparing it without you needing to know the cooking instructions. Finally, there's the virtual DOM. This is React's secret weapon for performance. Traditional web browsers build a tree-like structure in memory representing the entire web page, known as the Document Object Model, or DOM. When you make changes to the page, the browser has to update this real DOM, which can be a slow operation, especially for complex updates, because it might trigger re-rendering the entire page or large sections of it. React avoids this pitfall. When you declare a change to your UI, React doesn't immediately update the real browser DOM. Instead, it creates a lightweight, in-memory copy of the DOM, known as the virtual DOM. When your application's data changes, React first creates a new virtual DOM tree. Then, it efficiently compares this new virtual DOM with the previous one. This comparison process, called diffing, is incredibly fast because it's happening entirely in memory. Once React identifies the absolute minimal set of changes needed to update the browser, it then applies only those specific changes to the actual browser DOM. This smart optimization means fewer direct manipulations of the slow browser DOM, resulting in a much faster and smoother user experience. Your users perceive a snappier, more responsive application, even with frequent updates. In essence, React offers a solution to the complexity of building dynamic user interfaces by providing modularity, breaking down your UI into manageable, reusable components; predictability, declaring what your UI should look like, letting React handle the updates; performance, smartly updating only what's necessary on the screen using the virtual DOM; maintainability, easier to understand and fix problems in a well-structured, component-based application. This powerful combination has made React a household name in web development. Major companies like Facebook itself, Instagram, Netflix, Airbnb, and numerous others rely on React to power their highly interactive and engaging user experiences. Its widespread adoption means a vast community, abundant resources, and a wealth of tools and libraries that integrate seamlessly with it. So, why are you learning React? Because you're stepping into a world where building sophisticated, high-performance, and enjoyable web applications isn't a tangled mess of code, but an organized, efficient, and even fun process. You're learning the skills to build the next generation of web experiences, tackling challenges that traditional methods simply aren't equipped to handle effectively. In the coming chapters, we'll move from these core concepts to the practical steps of setting up your development environment and writing your very first React components, unlocking the power of this revolutionary library. Chapter 2, Setting Up Your React Workspace. Before we dive into writing our first lines of React code, we need to set up our development environment. Think of it like a carpenter preparing their workshop. You need the right tools in the right places before you can start building. Fortunately, getting a React project up and running is straightforward with modern tools. At a minimum, you'll need 3 things: Node.js. This is a JavaScript runtime environment. Even though React runs in your browser, Node.js is essential for our development tools, such as the package manager and the build tools that transform our React code into something browsers can understand. A package manager, npm, or yarn. These tools come bundled with Node.js and are used to install, manage, and share JavaScript libraries and packages, including React itself and all its dependencies. A code editor. This is the software you'll use to write your code. While any text editor will work, modern code editors offer features like syntax highlighting, auto-completion, and integrated terminals that significantly boost productivity. Visual Studio Code, often simply called VS Code, is a popular and powerful choice for web development, and it's what most developers use for React. Let's start with Node.js. If you don't have it installed already, the best way to get it is by visiting the official Node.js website, which is nodejs.org. You'll find download options for your operating system. It's generally recommended to choose the LTS or long-term support version, as this is the most stable and widely used. Installing Node.js will also automatically install npm, which stands for Node Package Manager, so you'll get 2 tools for the price of 1. After installation, you can verify it by opening your computer's command prompt or terminal and typing node v. That's node followed by a space and a -v, and then npm v. If you see version numbers displayed, you're good to go. If you need more detailed installation instructions, please refer to the Setup appendix at the end of this book. Once Node.js and NPM are ready, the quickest and most modern way to start a new React project is by using a tool called Vite. Vite, pronounced vite, like the French word for fast, is a next-generation front-end tooling that significantly improves the development experience, especially for new projects. It's incredibly fast at starting a development server and updating your application as you make changes. While you might encounter references to Create React App, or CRA, in older tutorials, Vite is the recommended and more efficient choice for new React projects today. Let's walk through how to create a new React project using Vite. Open your command prompt or terminal application. Navigate to the folder where you want to create your new project. For instance, you might have a Documents folder, and inside that, a Projects folder. You can use the cd command, which stands for Change Directory, followed by the path to your desired location. Once you are in your preferred location, you'll use npm to run a command that creates a Vite project. The command looks like this: npm create Vite at latest. After you type that command and press enter, Vite will ask you a few questions. First, it will ask for a project name. You can type something like My First React App and press enter. Stick to lowercase letters and hyphens for project names, as this is a common convention and avoids potential issues. Next, it will ask you to select a framework or library. Use your arrow keys to navigate down to React and press enter. Finally, it will ask you to select a variant. You'll want JavaScript or JavaScript plus SWC if available and preferred, as it's a very fast transpiler, but plain JavaScript is perfectly fine. Press enter. After these selections, Vite will quickly create a new folder with your project name, My First React App in our example, and generate all the necessary files inside it. You'll then see a message telling you to navigate into that new directory and run a couple of commands. So, the next step is to change your directory into your new project folder. If your project is named My First React App, you'd type cd My First React App. Once you're inside your project folder, you need to install all the required dependencies. These are the external libraries and packages that React and Vite need to function. You do this by typing npm install. This command will read a file called package.json in your project, which lists all the dependencies, and then download them into a folder named Node Modules. This might take a minute or two, depending on your internet speed. When it's done, you'll see some messages indicating success. Now, you're ready to start your development server. This server allows you to see your application running in your web browser as you develop it, and it automatically updates when you save changes to your code. To start the development server, type npm run dev. As soon as you execute this, you should see messages in your terminal indicating that the server has started. And crucially, it will tell you a network address where your application is running. Typically something like http localhost :5173 or a similar port number. Open your preferred web browser, like Chrome, Firefox, or Edge, and type that address into the address bar, then press enter. Voila! You should see the default Vite Plus React welcome page. It's usually a simple page with the React logo spinning and some introductory text. This confirms that your environment is correctly set up and your first React application is successfully running. Let's briefly look at the basic folder structure that Vite generated inside your My First React App directory. While you don't need to memorize every file, understanding the main parts will be helpful. Node Modules/. This folder contains all the external packages and libraries your project depends on. You typically don't interact with this folder directly. Public/. This folder is for static assets that are directly served by the web server, like images or a favicon file. src/. This is the most important folder for you. It's where all your React application source code will live. Inside src, you'll find app.jsx. This is your main application component. When you open the running app in the browser, the content you see comes from this file. Main.jsx. This file is your application's entry point. It's the very first JavaScript file that runs when your application loads in the browser. It essentially tells React to render your primary app component onto the web page. Index.css and app.css, these are your styling files. Gitignore. This file tells version control systems like Git which files and folders to ignore, like node modules / which can be very large. Index.html. This is the simple HTML file that serves as the entry point for your entire web application. Unlike traditional HTML pages, this file is quite bare. It primarily contains one div element, usually with an id of root, where your entire React application will be mounted and displayed. All the magic of your React components happens inside this div. Package.json. This file acts as a manifest for your project. It lists your project's name, version, and, critically, all the direct dependent packages required for your project to run. These are copied to node modules when you run npm install. It also defines scripts like dev, which runs npm run dev that automate common tasks. Vite.config.js. This file contains configuration settings for Vite itself. For most basic projects, you won't need to change this much, as Vite provides excellent defaults. With your environment set up and your basic React application running, you have successfully laid the groundwork. You've seen the power of Node.js, npm, and Vite in creating the framework for your development. In the next chapter, we'll delve into app.jsx and the concept of JSX, which is how we write HTML-like code directly within our JavaScript files to create our React components. Get ready to start coding. Chapter 3, JSX, the language of React. In the previous chapter, we successfully set up our React development environment and saw a basic React application running in the browser. You might have noticed a file called app.jsx in your project's src folder. If you opened it, you probably saw something that looked like HTML mixed with JavaScript. This unique syntax is called JSX, and it's the language of React. At first glance, JSX might seem a little strange. It looks like HTML, but it's being written inside a JavaScript file. This apparent hybrid nature is precisely what makes JSX so powerful, and once you get used to it, incredibly intuitive for building user interfaces. So, what is JSX? JSX stands for JavaScript XML. It's a syntax extension for JavaScript that allows you to write HTML-like code directly within your JavaScript files. Think of it as a convenient shorthand, or syntactic sugar, that makes writing React components much more readable and expressive. Without JSX, creating React elements would involve many verbose function calls, which would quickly become cumbersome for even moderately complex user interfaces. Let's imagine you want to display a simple paragraph. Hello React. In plain HTML, you'd write an opening paragraph tag, then Hello React, then a closing paragraph tag. In React with JSX, you write it almost identically. You type an opening angle bracket, then the letter P, then a closing angle bracket. Inside that, you write Hello React, and then an opening angle bracket, a /, the letter P, and a closing angle bracket, just like HTML. Now, here's the crucial part. This JSX code is not directly understood by your web browser. Browsers only understand standard JavaScript, HTML, and CSS. So, how does it work? This is where our build tools, like Vite, which uses a transpiler called sbuild or Babel behind the scenes, come into play. Before your React code is sent to the browser, these tools transpile your JSX code into regular JavaScript function calls. For example, our simple JSX paragraph p tag, Hello React, closing p tag gets transformed into something like React create element, p, null, Hello React. This create element function is what React actually uses to build what's called a React element, which is a lightweight description of what you want to appear on the screen. While it's good to understand that this transformation happens, you almost never write React create element directly. You write JSX, and the tools handle the rest. This abstraction is a core reason why React is so productive. You write familiar HTML-like structures, and React efficiently manages how they become real elements in the browser. One of the most powerful features of JSX is its ability to embed JavaScript expressions. You can put any valid JavaScript expression inside curly braces within your JSX, and React will evaluate that expression and render its result. For instance, suppose you have a JavaScript variable named username set to Alice. If you wanted to display Hello Alice. Within a heading, you could write an opening h1 tag, then Hello, then an opening curly brace, the variable username, a closing curly brace, and finally, a closing h1 tag. React will substitute the value of username into the text. You can embed variables, numbers, strings, or even the result of function calls. You could have a function get current time and embed it directly. The time is curly brace, get current time followed by parentheses, closing curly brace. Here are some important rules and considerations when working with JSX. Single root element. A React component, when rendering JSX, must always return a single root element. This means if you want to render 2 paragraphs and a button, they all need to be wrapped inside a single parent element. This parent can be a div element, a section element, or any other valid HTML tag. A very common pattern, especially when you don't want to add an unnecessary div to your HTML output, is to use a React fragment. You declare this by simply using an empty opening and closing angle bracket for the wrapper. So, opening angle bracket, closing angle bracket for the start, and opening angle bracket, / closing angle bracket for the end. This allows you to group multiple JSX elements without introducing an extra node into the actual DOM. Camel case for HTML attributes. While JSX looks like HTML, it is still JavaScript under the hood. Most HTML attributes are converted to camel case in JSX. For example, instead of class for CSS classes, you use class name, because class is a reserved keyword in JavaScript. Similarly, for attributes on labels become HTML4. Event handlers also follow camel case, so onClick becomes onClick, onChange becomes onChange, and so on. Self-closing tags. Any JSX element that doesn't have child content, like an image tag or an input tag, must be explicitly self-closed. You do this by adding a / before the closing angle bracket. So instead of imgsrc equals my-image.jpg, it's imgsrc equals my-image.jpg. The same applies to input tags. Input type equals text. No HTML comments. You cannot use standard HTML comments like, "This is a comment" inside JSX. Since JSX is JavaScript, you use JavaScript comments instead. For single-line comments, use 2 /. For multi-line comments, use a / followed by an asterisk, then your comment, then an asterisk followed by a /. Remember that comments within JSX, inside the UI structure, must be wrapped in curly braces, just like any other JavaScript expression. Styling in React. You can apply styles to your JSX elements in a couple of ways. External CSS files. The most common approach is to link external CSS style sheets, just like in traditional web development. You'll often import them directly into your JavaScript files. For example, your app.jsx might import a file named app.css. Inline styles. You can also apply inline styles directly to JSX elements using a JavaScript object. The property names in this object are camel case versions of CSS properties. For instance, to set text color to blue and font size to 20 pixels on a paragraph, you would type style equals followed by an opening curly brace, then another opening curly brace, then color. Blue, font size, 20px, then a closing curly brace, and finally a closing curly brace. Notice the double curly braces. The outer ones indicate a JavaScript expression, and the inner ones define the JavaScript object for the styles. Styles like background color would become background color. Understanding JSX is fundamental to writing React applications. It allows you to describe your UI in a way that feels natural for web developers, bridging the gap between JavaScript and HTML. While it might take a moment to get used to the class name versus class and the single root element rules, its benefits in terms of readability and component composition far outweigh the initial learning curve. In the next chapter, we'll take a deeper dive into the concept of components, the true building blocks of React applications, and see how we can use JSX to create our own reusable UI pieces. Chapter 4. Components, the building blocks of React. In the previous chapter, we explored JSX, the powerful syntax that lets us blend HTML-like structures directly into our JavaScript code. Now, it's time to put JSX to its primary use, building React components. If React applications are like elaborate machines, Then components are all the individual gears, levers, and buttons that make up that machine. They are the true foundation of every React application. At its heart, a React component is a self-contained, reusable piece of code that defines a part of your user interface. Think of a navigation bar, a product card in an online store, a login form, or even a single button. Each of these can be a component. Why are components so central to React? There are several compelling reasons. Reusability. Once you create a component, you can use it many times throughout your application or even in different applications without rewriting the same code. This dramatically reduces development time and effort. Imagine building a user avatar component. You could use it in a conversation list, a profile page, or a comment section, each time displaying a different user's avatar without duplicating code. Modularity and organization. Components encourage you to break down complex UIs into smaller, manageable, and understandable pieces. This makes your code base easier to navigate, maintain, and debug. Instead of one giant file trying to handle everything, you have a clear structure where each file and each component has a specific responsibility. Readability. When you look at an app component, you might see opening angle bracket, navbar, / closing angle bracket, then opening angle bracket, sidebar, / closing angle bracket, and opening angle bracket, main content, / closing angle bracket. This instantly tells you the overall structure of your page, even if you don't know the exact details of how navbar or sidebar work. Testability. Since each component is self-contained, it's easier to test them in isolation to ensure they behave as expected. In modern React, most components are written as functional components. These are simply JavaScript functions that return JSX. Let's look at a simple example. Imagine we want to create a welcome message component that displays a greeting. First, you would create a new JavaScript file in your src folder, perhaps named welcome message.jsx. Inside this file, you would define your function, welcome message.jsx, function welcome message, return p hello react world /p. To export default welcome message, let's break this down. Function welcome message. This defines a standard JavaScript function named welcome message. In React, component names must start with an uppercase letter. This is a crucial convention that allows React and the build tools to distinguish between a regular HTML element, like div or p, which start with lowercase, and a custom React component. Return, this is where our familiar JSX comes in. The function returns a single element, in this case, a paragraph tag, containing our greeting. Remember the rule from the last chapter. A component must return a single root element or a React fragment. Export default welcome message. This line is standard JavaScript syntax for exporting the welcome message function, making it available for other files to import and use. Export default means this is the primary thing this file makes available. Now that we have our welcome message component, how do we use it? We import it into another component, typically app.jsx, and then render it as if it were a regular HTML tag. Open your app.jsx file, usually found in your src folder, and modify it to look something like this. app.jsx. Import welcome message from welcome message. Import the component. Function app. Return. Div. H1 my first React app H1. Welcome message, render the component. P this paragraph is part of the app component P. Div. Export default app. Notice the lines. Import welcome message from welcome message. This line imports our welcome message component. The before welcome message indicates that the file is in the same directory as app.jsx. Welcome message. This is how you render a component using JSX. Just like self-closing HTML tags, custom React components are self-closed with a / before the closing angle bracket. When React sees welcome message, it knows to execute the welcome message function and render whatever JSX it returns. If you save these files and your development server is still running, you started it with npm run dev in the previous chapter, your browser should automatically refresh, and you'll see Hello React World rendered on the page, along with my first React app and the additional paragraph from the app component. Congratulations, you've just created and rendered your first custom React component. passing data with props. Our welcome message component is currently static. It always says, "Hello, React World." What if we want it to say, "Hello, Alice," or "Hello, Bob"? This is where props come into play. Props, short for properties, are how you pass data from a parent component down to a child component. They are essentially arguments that you pass to your functional React components. Let's modify our welcome message component to accept a name prop. Welcome message JSX. Function welcome message props. Props is a parameter here. Return p-hello props.name /p/use props.name to export default welcome message. Now, the welcome message function takes a single argument, props. This props argument is an ordinary JavaScript object, and any attribute you define on the component when you use it in JSX will become a property on this props object. Inside the return, we use curly braces to embed the JavaScript expression props.name into our JSX. Next, we modify app.jsx to pass the name prop. App.jsx, import welcome message from welcome message, function app. Return div h1 my first React app h1. Welcome message name equals Alice, /pass the name prop. Welcome message name equals Bob, /pass a different name prop. P this paragraph is part of the app component P. Div to export default app. We've added name equals Alice as an attribute to our welcome message component. This attribute name becomes a property on the props object inside welcome message, accessible as props.name. We can even render the welcome message component multiple times, passing different name props to each instance, showcasing the reusability. Save your files and you'll see "Hello, Alice" and "Hello, Bob" rendered on your page. Props can be strings, numbers, Boolean values, functions, objects, or arrays. When passing non-string values, you use curly braces to embed the JavaScript expression. For example, to pass a number, product price equals 100. To pass a Boolean, button is active equals true. To pass an object, user details user equals first name, Jane last name, Doe. Components can also receive children. Anything you place between the opening and closing tags of your component in JSX becomes a special children prop. For example, card JSX. Function card props. Return div class name equals card. Props children, render whatever is passed as children. Div to export default card, app.jsx. Import card from card, function app. Return div card h to product title h2. P sum product description goes here P. Button by now button. Card P another card with different content P. Card div to export default app. In the card component, props children will render the h2, P, and button elements for the first card, or just the P element for the second card. Building applications with components is about breaking down your UI into a hierarchy of smaller, focused pieces of functionality. The app component acts as a parent, rendering welcome message components as children. The welcome message component might in turn have its own children, though not in our simple example. Data flows in React in a top-down, unidirectional manner, from parent components to child components via props. This props flow is fundamental to understanding how data moves through your React application. You now understand the backbone of React development. In the next chapter, we'll delve into a crucial topic: how to manage dynamic data within a component itself using something called state and the useState hook. Chapter 5, State Management with useState. In the previous chapter, we learned how to build components and pass data between them using props. Props are excellent for passing information down the component tree from a parent component to its children. However, what if a component needs to manage its own internal data that can change over time, perhaps in response to user interaction? For instance, think of a counter that increments when you click a button, a glowing light switch that turns on and off, or an input field where the text someone types needs to be stored and reflected as they type. This dynamic, internal data is what we call state. Unlike props, which are read-only and passed into a component, state is data that a component owns and manages itself. When a component's state changes, React efficiently re-renders that component and any of its child components that are affected by the change, ensuring your user interface stays up-to-date and responsive. In modern React, we manage state in functional components using a special function called the useState hook. Hooks are functions that let you hook into React features from functional components without writing class components. useState is the most fundamental of these hooks for managing state. To use useState, you first need to import it from the React library. You would typically add useState inside the curly braces following import React if you were already importing React, or simply import useState from React at the top of your component file. Let's look at how useState is declared and used within a functional component. When you call useState, it returns an array with two elements. The first element is the current state value, and the second is a function that lets you update that state value. You use array destructuring syntax, which is a modern JavaScript feature, to assign names to these two elements. Here's the pattern. Const variable name, set variable name, equals useState, initial value. Let's break this down. Variable name. This is a name you choose for the state variable itself. This variable will hold the current value of your state. For example, if you're tracking a count, you might call it count. Set variable name. This is the function you must call to update the variable name. By convention, it's usually named set followed by the name of your state variable, e.g., setCount. It's crucial to understand that you should never directly modify variable name, like count equals count plus 1. Always use this set function to update the state. useState, initial value. This is the useState hook itself. You pass it a single argument, initial value, which is the default value for your state when the component first renders. This initial value can be a primitive like a number, string, or Boolean, or a more complex data structure like an object or an array. Let's illustrate with a classic example, a simple counter. We'll create a component that displays a number and has a button to increment it. First, create a new file, say counter.jsx, in your src folder. Counter.jsx. Import React, useState from React. Import useState. Function counter. Declare a state variable named count with an initial value of 0. setCount is the function to update count. Const count setCount equals useState, 0. Define a function to handle the button click. Const handle increment equals setCount count plus 1. Update the count state by calling setCount. Return div pCurrent count count/p. Button on click equals handle increment /button. Div to export default counter. Now, import and render this counter component in your app.jsx file. App.jsx. Import counter from counter, function app. Return div h1 my awesome counter app h1 counter/our counter component. Div to export default app. Save these files and observe your browser. You should see current count, 0, and an increment button. Each time you click the increment button, the number displayed will increase. Let's trace what happens when you click the button. The onClick event handler on the button triggers the handle increment function. Inside handle increment, we call setCount, count plus 1. For the first click, count is 0, so setCount, 0 plus 1, effectively calls setCount 1. Calling setCount tells React, hey, the count state has changed, please re-render this counter component. React re-renders the counter component. During this re-render, the useState, 0 line is re-executed, but since count now has a value of 1, useState returns 1, setCount, instead of the initial 0, setCount. Thus, the count variable inside the component now holds 1. The JSX in the return statement now evaluates count as 1, so the paragraph displays current count, 1. This process continues for each click, creating a dynamic and interactive user interface. Important considerations when updating state. State updates are asynchronous, often batched. React might batch multiple state updates together for performance reasons. This means that if you call setCount multiple times in quick succession within the same event handler, the count value used in setCount might not be the absolute latest value. If your next state depends on the previous state, it's best practice to pass a function to your setter. This function receives the previous state as its argument. For our counter, if you wanted to be absolutely sure the increment relied on the very latest count, you'd write it like this. setCount prevCount equals prevCount plus 1. Here, prevCount is guaranteed to be the most up-to-date value of count at the time of the update. Immutability for objects and arrays. When your state holds objects or arrays, always update them by creating a new object or array, rather than directly modifying the existing one. React performs a shallow comparison to determine if the state has changed. If you mutate an object or array in place, its reference in memory remains the same, and React won't detect the change, thus not triggering a re-render. To update an object, use the spread syntax. To create a new object and then override any properties you want to change. Let's say your state is an object. Const user set user equals useState. Name, Alice, age 30. To update the age, set user, user age 31. This creates a new object, copying all properties from the user object and then explicitly setting age to 31. Similarly, for arrays, const items set items equals useState apple, banana, to add a new item. Set items items orange. This creates a new array, copying all existing items and adding orange to the end. To remove an item, e.g. banana, set items filter item equals banana. The filter method returns a brand new array, which is exactly what React expects. Understanding and correctly using useState is pivotal to building interactive React applications. It allows your components to respond to user input, fetch data, and manage their own internal logic. By combining the power of useState for internal data with props for external data flow, you have the fundamental tools to create dynamic and responsive user interfaces. In the next chapter, we're going to dive into another essential React hook, useEffect. While useState handles data that changes, useEffect handles tasks that need to run after components render, like fetching data from a server or interacting with the browser's document. Chapter 6, the useEffect hook, managing side effects. In the journey of building interactive web applications, we reach a point where components need to do more than just render data and respond to simple user clicks. Sometimes, a component needs to perform operations that interact with the outside world after it has rendered. These operations are known as side effects. What exactly are side effects in React's context? They are anything that impacts something outside the scope of a component's render cycle. Common examples include data fetching, getting information from an external API, like fetching a list of products or user data. DOM manipulation, directly changing the browser's document object model, perhaps setting the document title, adding an event listener to the window object, or interacting with a special JavaScript library that needs direct access to a DOM element. Setting up subscriptions, listening for events from a WebSocket server, a third-party library, or local storage. Timers, using set timeout or set interval for delayed actions or recurring tasks. Previously, in class components, these side effects were managed using lifecycle methods like component.didMount, component.didUpdate, and component.willUnMount. For functional components, React provides the useEffect hook to handle all these scenarios in a more unified and often simpler way. To use useEffect, you need to import it from React, just like useState. Import React, useEffect from React. The useEffect hook accepts two arguments. A function. This is the effect function itself, where you put the code that performs the side effect. This function will run after every render of your component by default. An optional dependency array. This is a crucial part of useEffect's behavior. It's an array of values that the effect depends on. If any value in this array changes between renders, the effect function will rerun. If the array is empty, the effect will run only once after the initial render, similar to component.didMount. If you omit the array entirely, the effect will run after every render, which is rarely what you want for most side effects like data fetching, as it could lead to infinite loops. Let's illustrate with a common use case. Setting the document title based on a component state. Imagine a component that displays a message, and we want the browser tab's title to reflect that message. Title changer JSX. Import React, useState, useEffect from React. Function title changer. Const message set message useState default title, our effect function. useEffect equals. This code runs after the component renders. Document title equals chat. Message console log document title updated. Message dependency array run effect only when message changes. Return Div h to document title updater h2. Input type equals text, value equals message, on change equals e equals set message e target value, placeholder equals type a new message, /p current message, message /p. Div to export default title changer. Now include this in your app.jsx. App.jsx. Import title changer from title changer. Function app. Return. Div h1 my React app h1. Title changer. Div to export default app. When you load this in your browser, initially the title changer component renders. Message is default title. After the render, useEffect runs for the first time. It sets document title to chat, default title. When you type into the input field, set message is called. This causes the title changer component to re-render. After the re-render, React checks the dependency array message. Since message has changed, e.g. from default title to default titlia, the effect function runs again. Document title is updated with the new message. This example clearly shows how useEffect lets us perform actions that react to changes in our component's state or props. Common useEffect scenarios and dependency arrays. Run once after initial render, like component did mount, to fetch data when the component first loads, to set up event listeners that should only be attached once. useEffect equals fetch user data here, or set up a global event listener. Console log, component mounted for the first time. Empty dependency array, runs only once after initial render, placing an empty array as the second argument tells React. This effect doesn't depend on any values from props or state, so just run it once when the component initially mounts and never again. Run on every render, no dependency array, generally avoid for non-trivial effects. This is the default behavior if you omit the second argument. The effect will run after every single render, including on initial mount and every subsequent re-render. Can easily lead to performance issues or infinite loops if not handled carefully, e.g., fetching data without conditions. useEffect equals. This will run after every render. Console log, component rendered or re-rendered. No dependency array. Run when specific values change, like component did update. When you want an effect to rerun only when certain props or state values change. useEffect equals. This will run when userit or filter changes. Fetch data user ID filter, user ID filter. Effect dependent on userid and filter. Cleaning up effects. Many side effects, especially those involving subscriptions or external resources, require a cleanup phase. For example, if you set up an event listener, you should remove it when the component unmounts to prevent memory leaks or unexpected behavior. The useEffect hook provides a way to do this. The effect function can optionally return a cleanup function. This cleanup function will run just before the component unmounts, and also before the effect runs for subsequent re-renders after the initial render. Import React, useState, useEffect from React, function timer. Const seconds, set seconds equals useState 0, useEffect equals. Set up the interval, runs every 1000 milliseconds. Const intervalid equals set interval equals. Set seconds, prev seconds equals prev seconds plus 1. 1000, this is the cleanup function. Return equals. Clear the interval when the component unmounts or before the effect reruns if dependencies change. Clear interval, interval IDs. Console log, timer cleanup performed. Empty dependency array, interval set up once. Return. Div. P seconds, seconds/p. Div. To export default timer. If you render this timer component and then remove it from the DOM, e.g., by conditionally rendering it and removing it from your app component, you'll see timer cleanup performed. In the console, when it disappears, preventing the set interval from continuing to run in the background, causing memory leaks. Rules of hooks. React hooks like useState and useEffect come with a couple of important rules that you must follow. Only call hooks at the top level. Don't call hooks inside loops, conditions, or nested functions. Always call them at the top level of your functional component, before any early returns. This ensures that hooks are called in the same order every time the component renders, which is crucial for React to correctly associate state and effects with their respective hooks. Only call hooks from React functions. Call hooks from React functional components or from custom hooks, which we'll touch upon later. Don't call hooks from regular JavaScript functions. Understanding useEffect is arguably one of the most challenging, but also most rewarding parts of mastering functional components in React. It's the primary tool for dealing with asynchronous operations, external interactions, and other side effects that ensure your application is not just reactive, but also integrated with its environment. Take your time experimenting with the dependency array and practice setting up cleanup functions. In the next chapter, we'll build on our knowledge of components, state, and effects to explore how to render content conditionally and how to efficiently display lists of data, further expanding our ability to create dynamic user interfaces. Chapter 7, Conditional Rendering and List Rendering. In the previous chapters, we learned how to build components, manage their internal data with useState, and perform side effects with useEffect. Now, let's explore two essential techniques that bring even more dynamism and flexibility to your React applications: conditional rendering and list rendering. Conditional rendering. Showing and hiding elements. Imagine an application where certain parts of the user interface should only appear when a condition is met. For example, a login form should display an error message only if the login attempt fails. A loading spinner should appear only while data is being fetched, or a button might be enabled or disabled based on user input. This concept of displaying different elements or components based on a specific condition is called conditional rendering. React applications are built using JavaScript, and because JSX is ultimately JavaScript, you can leverage standard JavaScript operators and statements to control what gets rendered. Here are the most common ways to implement conditional rendering. Using if statements outside JSX. This is straightforward JavaScript. You can use an if statement to decide which JSX to return from a component or to control which JSX gets assigned to a variable. For example, let's say you have a component that should show a welcome message if a user is logged in and a login prompt if they are not. You could define your user greeting component. Function user greeting props. If props is logged in, return p_welcome /p. Return p please sign up p. In this example, the user greeting component checks the is logged in prop. If it's true, it immediately returns the welcome back paragraph. Otherwise, it proceeds to the next line and returns the please sign up paragraph, using the logical AND operator, and. This is a concise way to conditionally render an element when you only want to render it if a condition is true, and render nothing otherwise when the condition is false. In JavaScript, true and an expression evaluates to expression, and false and an expression evaluates to false, which React ignores in JSX, effectively rendering nothing. This is useful for displaying error messages, warnings, or optional components. Consider a component that shows a new messages. Alert only if there are messages. Function mailbox props. Const unread messages equals props unread messages. Return. Div h1 hello /h1. Unread messages length 0 end. Pu have unread messages length, unread messages p. Div. Here, if unread messages length is greater than 0, the message paragraph will be rendered. If it's 0 or less, the condition is false, and nothing will be rendered where that expression is placed. Using the ternary operator. The ternary operator is perfect when you need to render either one thing or another based on a condition. If this, then that, else this other thing. Let's rewrite our user greeting example using a ternary operator, which is often preferred when the logic is simple enough to fit on one or two lines as part of the return statement's JSX. Function user greeting props. Return. Div. Props is logged in. p_welcome /p. P please sign up p. Div. Here the is logged in prop is checked. If true, the first p tag is rendered. If false, the second p tag is rendered. The parentheses around the JSX expressions are optional but can improve readability, especially for more complex JSX. These methods provide flexible ways to control the flow and appearance of your UI based on dynamic data. You can choose the method that best fits the complexity and clarity of your specific conditional rendering needs. List rendering. Displaying collections of data. Almost every real-world application needs to display lists of items. User comments, product listings, news articles, task lists, and so on. In React, you typically receive your data as a JavaScript array, and you need a way to transform each item in that array into a React element or component. The most common and preferred way to render lists in React is by using the JavaScript array map method directly within your JSX. The map method creates a new array by calling a provided function on every element in the calling array. When used in JSX, this function typically returns a React element for each item. Let's imagine you have an array of names and you want to display each name as a list item. Function name list. Const names equals Alice, Bob, Charlie, Diana. Return div h2 users h2. ul names map name index equals li key equals index name slash lie. Ul div. Let's break this down. Names map name index equals. We call the map method on our names array. For each name in the array, the function provided to map will execute. Li key equals index name li. Inside the map function, we return a list item li element. The name variable, representing the current item in the array, is embedded directly into the list item. The crucial key prop. You'll notice an attribute called key on the li element, key equals index. This key prop is incredibly important when rendering lists in React, and if you forget it, React will give you a warning in the console. Here's why key is essential. Identity for React. When React renders a list, it needs a way to uniquely identify each item in that list, especially if the list changes, items are added, removed, reordered. The key prop serves as a stable identity for each component or element in the list. Performance and state preservation. Without unique keys, React has to re-render the entire list inefficiently when changes occur, potentially destroying and recreating elements that haven't actually changed. With stable keys, React can efficiently determine exactly which items have been added, removed, or reordered, allowing it to update the DOM precisely and preserve the internal state of components. This leads to much better performance and a smoother user experience, especially in long or frequently changing lists. What to use as a key? Unique and stable IDs. The absolute best value for a key is a unique and stable ID associated with the data itself. If your data comes from a database or API, it usually has a unique ID, e.g., a product ID, a user ID. Use that const products equals id1 name, laptop, id2 name, mouse, id3 name, keyboard. Function product list. Return ul products map product equals li key equals product, dproduct.name/lie, use producted as key. Ul index as a fallback with caution. Using the array index as a key equals index is generally discouraged if the order of items in the list can change or if items can be added, removed, or reordered. If you add an item in the middle of a list, all subsequent items shift their indices, confusing React's reconciliation process. This can lead to unexpected behavior, performance issues, or incorrect component state. When index is acceptable, only use index as a key if the list items are static and will never change order, be added, or removed, e.g., a hard-coded navigation menu. In these rare cases, it's harmless. To recap, conditional rendering allows you to display dynamic content based on logic, making your UIs smart and adaptable. List rendering, powered by the map method and the crucial key prop, enables you to efficiently display collections of data, creating dynamic interfaces like product catalogs or comment sections. These two techniques are fundamental to building any non-trivial React application. In the next chapter, we'll turn our attention to how React handles user interaction, specifically focusing on event handling and working with forms, which are essential for any interactive web application. Chapter 8, Event Handling and Forms. So far, we've focused on displaying information and making parts of our application dynamic using state. But a truly interactive web application requires user input. Whether it's clicking a button, typing into a text field, or selecting an option from a dropdown, our React components need to respond to these user actions. This is where event handling comes in. In the world of web development, an event is any action or occurrence that happens in the browser that your JavaScript code can listen for and respond to. Common examples include a mouse click, a key press, a form submission, or a page load. Event handling in React. React's approach to handling events is very similar to standard HTML and JavaScript, but with a few React-specific differences and conventions that simplify development. Camel case event names. In plain HTML, event names are usually lowercase, like onClick or onChange. In React JSX, event names are written in camel case, which is a common JavaScript convention. So, onClick becomes onClick, onChange becomes onChange, onSubmit becomes onSubmit, and so on. Passing functions as handlers. Instead of passing a string of JavaScript code to an event handler, which you might see in older HTML JavaScript examples, you pass a JavaScript function directly, enclosed in curly braces. This function will be executed when the event occurs. Let's revisit our counter example from Chapter 5. There, we had a button that incremented a count. Inside counter JSX. Function counter. Const count set count equals useState 0. Const handle increment equals. This is our event handler function. Set count count plus 1, a return. Div p current count /p. We pass the handle increment function reference to onClick. Button onClick equals handle increment /button. Div. When the user clicks the button, React calls the handle increment function. We name our event handler functions with handle prefix followed by the event type, e.g., handle click, handle change, handle submit by convention, making them easy to identify. The synthetic event object. When an event handler function is called, React automatically passes it a special object called the synthetic event. This object is a cross-browser wrapper around the browser's native event. It provides a consistent interface regardless of the browser, ensuring your event handling works reliably everywhere. You can access properties on this object, like event target, the DOM element that triggered the event, or event prevent default. To stop the browser's default behavior, like a form submission reloading the page. Let's say you want to get the value from an input field. The onChange event on an input will provide the synthetic event object, from which you can get the target element's value. Inside a component. Function myInput. Const text set text equals useState. Const handle change equals event. Event is the synthetic event object. Set text event target value. Access the value of the input. Return. Div. Input type equals text, onChange equals handle change, value equals text. Pu typed, text/p. Div. In this example, as you type, handle change is called. Event target value captures what you just typed, and set text updates the state, which then re-renders the paragraph with the new text. Preventing default behavior. Some HTML elements have default browser behaviors associated with their events. The most common example is a form submission, which by default causes the page to reload. To prevent this, you can call event prevent default inside your event handler. We'll see this in action when we discuss form submission. Forms, taking user input. Forms are a critical part of almost every web application, allowing users to provide data. In React, forms work a bit differently than traditional HTML forms. In HTML, form data is often handled by the browser directly when you submit a form. In React, because we want our UI to be a reflection of our component state, we use what are called controlled components to manage form input. Controlled components. A controlled component is an input form element whose value is controlled by React state. This means the input's value is always driven by the state, and every time the input's value changes, e.g., the user types something, you update the state, which then re-renders the input with its new value. This might sound like an extra step, but it gives you complete control over the form data within your React component. It simplifies validation, enabling disabling parts of the form, and conditionally formatting input. Let's build a simple login form with controlled components. Login form JSX. Import React, useState from React, function login form. State for username and password. Const username, set username equals useState. Const password, set password equals useState. Event handler for username input change. Const handle username change equals, event equals. Set username, event target value. Event handler for password input chain. const handle password change equals event equals set password event target value event handler for form submission. Const handle submit equals event prevent default browser form submission page reload. Console log logging in with username password. Here you would typically send data to a server. For now, let's just clear the fields. Set username, set password, return, form on submit equals handle submit, / on submit for the form. Div, label HTML for equals username, / label. Input, type equals text, ID equals username, value equals username, input value controlled by state. On change equals handle username change, update state on chain. Div, label HTML for equals password, / label. Input, type equals password, ID equals password, value equals password, input value controlled by state. On change equals handle password change, update state on chain. Div, button type equals submit login / button. Form, to export default login form, and in your app.jsx to render it, app.jsx. Import login form from login form, function app. Return, div, h1 user login h1. Login form, div, to export default app. When you load this in your browser, the username and password states are initialized as empty strings. The input elements have their value attribute bound to these state variables. This is what makes them controlled. When you type into the username field, the onChange event fires, calling handle username change. Handle username change captures the new input value from event target value and calls setUsername to update the state. Updating the state causes React to re-render the login form component. The input field's value attribute is now updated to the new character you typed, reflecting it on the screen. The same process occurs for the password field. When you click the Login button, the onSubmit event on the form element fires, calling the handle submit function. Event prevent default stops the browser from reloading the page. Then you can access the current username and password values directly from your state variables, ready to be processed, e.g., sent to a server. Other form elements, Textaria, works just like a text input. You control its content using the value prop and update it with onChange. There is no children attribute for Textaria in React. Example, Textaria value equals my text, onChange equals handle text change. Select. For dropdowns, you control the selected option by setting the value prop on the select tag itself, not on the option tags. The onChange handler on the select tag will provide the currently selected value. Example, const selected fruit, set selected fruit equals useState apple. Const handle fruit change equals event equals set selected fruit, event target value. Return, select value equals selected fruit, onChange equals handle fruit chain. Option value equals apple / option. Option value equals banana / option. Option value equals orange / option. Select checkboxes and radio buttons. For input elements with type equals checkbox or type equals radio, you typically use the checked prop, a Boolean, instead of value to control their state and update it via onChange. Example checkbox, const is checked, set is checked equals useState false, return. Input, type equals checkbox, checked equals is checked, onChange equals, equals set is checked, target checked. Mastering event handling and controlled components is fundamental. It empowers your React applications to be truly interactive, allowing users to input data and trigger complex logic within your components. This interaction forms the backbone of all dynamic web experiences. With forms and user events now covered, you're equipped to build UIs that not only display information, but also actively respond to and gather input from your users. In our next chapter, we'll delve into some more advanced React hooks and explore the Context API, which provides more sophisticated ways to manage state and data flow across components, especially when dealing with deeply nested component trees. Chapter 9, Advanced Hooks and Context API. So far, we've mastered the foundational React hooks. useState for managing a component's internal data, and useEffect for handling side effects like data fetching or direct browser interactions. These two hooks alone are incredibly powerful and will cover the vast majority of your component's needs. However, as your applications grow, you might encounter scenarios where state management becomes more complex, or where passing data through many layers of components becomes cumbersome. In this chapter, we'll explore some more advanced hooks and a powerful built-in React feature called the Context API, which help address these challenges. The problem of prop drilling and the solution. Context API with useContext. Imagine you have a piece of data that many components in your application need access to, even if they're not directly related as parent and immediate child. Common examples include a user's authentication status, the current theme, light or dark mode, or language preferences. You could pass this data down using props from the top-level app component through several intermediate components until it reaches the deeply nested components that actually need it. This phenomenon is often jokingly referred to as prop drilling or prop tunneling. It makes your code less readable, more verbose, and harder to refactor, as a change to the data means adjusting props in every intermediate component along the chain. The React Context API provides an elegant solution to prop drilling. It allows you to create a global data store that any component, regardless of its depth in the component tree, can subscribe to and access without explicitly passing props down through every level. The Context API involves three main steps. Creating a context. You start by creating a context object. You import create context from React and then call it, optionally passing an initial default value. This create context function returns an object with two components, a provider and a consumer. While consumer was used more with class components, with hooks, we primarily use the provider and the useContext hook. Think of create context as defining a channel or a global variable that components can tune into. Auth context.js, a separate file for clarity. Import create context from React. Create a context with a default value, e.g., null for no user. Const auth context equals create context null. Export default auth context. Remember, in an audiobook, I described the file name and content in detail. This auth context object now contains our provider and consumer, providing the context. The provider component is used to provide the data to all its descendant components. You wrap the part of your component tree that needs access to the context data with the provider. The data you want to share is passed as a value prop to the provider. Typically, this provider is placed high up in your component tree, often in your app.jsx or a layout component, to make the data available to a wide range of components. App.jsx, or a top-level component. Import React from React. Import auth context from auth context. Import the context we created. Import welcome text from welcome text. A deeply nested component. Function app. Const current user equals name. Alice is logged in, true. This is our shared data. Return. Auth context dot provider value equals current user. Div. H1 my application H1. P this paragraph doesn't need user info P. Imagine many components nested here. Slash the welcome text component needs user info. Welcome text. Div. Auth context dot provider. Export default app. Here, all components within the auth context dot provider, like welcome text and any components it contains, will have access to current user. Consuming the context with useContext. Any functional component that wants to access the data provided by a context provider uses the useContext hook. You simply pass the context object you created, e.g., auth context, to useContext, and it returns the current value of that context. Welcome text.jsx, a component that could be anywhere in the tree under provider. Import React, useContext from React. Import auth context from auth context. Import the same context. Function welcome text. Use the useContext hook to get the current value from auth context. Const user equals useContext auth context. If user and an user is logged in. Return p welcome user.name/p. Return p please log in p. Export default welcome text. Notice that welcome text does not receive user as a prop. It directly grabs it from the auth context using useContext. This effectively bypasses the need to pass user through any intermediary components. Context is not a replacement for useState or useReducer. It's a way to efficiently deliver state or any other data to parts of your application that are separated by many component levels. For component-specific state, or state, that only needs to go down 1 or 2 levels, props and useState remain the best approach. Managing complex state logic with useReducer. While useState is excellent for simple state variables, like a number, string, or Boolean, some state transitions can be more complex. Imagine a shopping cart where you have multiple items, quantities, and prices, and actions like add item, remove item, update quantity. Managing this with multiple useState calls and complex update logic can become cumbersome. The useReducer hook provides an alternative to useState for managing more complex state logic. It's often preferred when state updates depend on the previous state. State logic involves multiple subvalues. The state transitions are more predictable and can be expressed as a series of actions. You want to separate state logic from the component itself. useReducer is conceptually similar to patterns found in libraries like Redux. It takes 2 arguments and returns the current state and a dispatch function. A reducer function. This is a pure function that takes the current state and an action object as arguments and returns the new state. It describes how the state should change in response to different actions. An initial state, the starting value of your state. The dispatch function is what you call to dispatch an action. An action is typically a plain JavaScript object that describes what happened, e.g., type, increment or type, add item payload, id 123 name, product X. The reducer function then processes this action to compute the next state. Let's look at a slightly more complex counter example with useReducer. Import React. useReducer from React. 1. Define the reducer function. Const counterReducer equals state action equals switch action type case increment return count state.count plus 1 return new state object case decrement return count state.count 1 case reset return count 0 default. If action type is unknown, throw an error or return current state. Throw new errors. Function complex counter. 2. Initialize useReducer with the reducer function and initial state. Const state dispatch equals useReducer, counter reducer, count 0, state is an object. Return div pcount state.count/p. Button on click equals dispatch type increment button. Button on click equals dispatch type decrement button. Button on click equals dispatch type reset button. Div to export default complex counter. Here's the flow. Counter reducer. This function defines all the possible ways our count state can change based on different action type values. useReducer, counter reducer, count. 0, we initialize useReducer, telling it which reducer function to use and what the initial state object should be, count starting at 0. It returns the current state object and a dispatch function. Dispatch, type, increment. When an action occurs like a button click, we call dispatch with an action object. This object has a type property, e.g., increment, that tells the reducer what kind of state update to perform. The reducer function receives the current state and the action. It processes the action based on its type and returns a new state object. React then re-renders the complex counter component with the new state. useReducer centralizes state logic, making it easier to manage and test state updates. It pairs particularly well with useContext when you want to manage complex global state that multiple components need to update. Direct DOM interaction with useRef. While React encourages a declarative approach where you describe what your UI should be, rather than directly manipulating the browser's DOM, there are some scenarios where directly referencing a DOM element or storing a mutable value that doesn't trigger re-renders is useful. The useRef hook is for these cases. useRef returns a mutable ref object whose current property is initialized to the passed argument, initial value. The returned ref object will persist for the full lifetime of the component. The primary use cases for useRef are accessing DOM elements. For example, programmatically focusing an input field, playing media, or measuring element dimensions. Storing mutable values that do not cause re-renders. If you need to store a value across renders, but don't want to change to this value to trigger a component re-render, unlike useState, useRef is suitable. Good for storing timer IDs, previous values, or expensive objects that you don't want to recreate on every render. Import React. useRef from React. Function focus input. Const inputref equals useRef null. Create a ref object. Const handleclick equals. Access the DOM element through inputref current and call its focus. Method. Inputref current focus. Return. Div. Input type equals text, ref equals input ref. / attach the ref to the input element. Button on click equals handle click focus, the input button. Div. To export default focus input. When the component renders, inputref current initially holds null. Once the input element is mounted in the DOM, React assigns that DOM element directly to inputref current. When the button is clicked, handleclick accesses this DOM element and calls its focus. Method. useRef versus useState. useState is for managing data that, when changed, should trigger a re-render of the component and update the UI. useRef is for mutable values that you need to hold on to, but whose changes do not need to trigger a UI update. When to use which? useState, your go-to for simple, component local state. If your state is a single primitive, number, string, boolean, or a simple object array, and its updates are straightforward, useState is usually sufficient. useReducer. Consider useReducer when your state logic is more complex, involves multiple subvalues, or updates depend on the previous state in intricate ways. It's also great if you want to explicitly define and centralize all possible state changes through dispatched actions. useContext. Use useContext when you need to share data that is considered global or applicable to many components deep in the tree, avoiding the chore of prop drilling. It works great for themes, user authentication, or language settings. It doesn't manage the state itself, but rather allows you to provide state, often managed by useState or useReducer, and consume it efficiently. useRef. Use useRef when you need to interact directly with a DOM element or store a value that should persist across renders, but whose changes should not trigger a re-render. These advanced hooks, along with the Context API, provide you with the tools to tackle more intricate state management problems and build larger, more maintainable React applications. While they might seem a bit more complex initially, they streamline the creation of highly interactive and robust user interfaces. In our next chapter, we'll shift our focus from individual components to how we build applications with multiple pages or views by learning about React Router, the popular solution for client-side navigation in React applications. Chapter 10, React Router, Navigating Your Application. Many modern web applications are built as single-page applications, SPAs. Unlike traditional websites where clicking a link leads to a full-page reload from the server, SPAs dynamically rewrite the current page with new content from the client side, typically fetching data via JavaScript. This provides a faster, smoother, and more desktop application-like user experience. However, building in SPA introduces a challenge. How do you manage different views or pages without a full page refresh, while still allowing users to bookmark specific URLs, use the browser's back-forward buttons, and share links? This is where client-side routing comes in, and for React applications, the most popular and robust library for this purpose is React Router. React Router keeps your UI in sync with the URL, allowing you to define different components that should render based on the current path in the browser's address bar. Installation. Before we can use React Router, we need to add it to our project. In your terminal, in your project's root directory, run the following command: npm install React Router DOM. The React Router DOM package provides the specific bindings for web applications, DOM, in React. Core concepts of React Router. React Router is built around a few core components that you'll use to define your application's navigation. Browser Router. This is the foundational component that wraps your entire React application wherever you want routing to be enabled. It uses the HTML5 history API to keep your UI in sync with the URL. You typically place it at the highest level of your component tree, often in your app.jsx or main.jsx file. Roots. This component is used to define a collection of individual root components. It looks at the current URL and renders the first route that matches. Route. This component is where you define a specific path and the component that should be rendered when that path is active. It takes a path prop, the URL segment to match, and an element prop, the JSX element to render when the path matches. Link. This component is used to create navigation links within your application. Instead of using a standard HTML tag, which would cause a full page reload, you use link to tell React Router to simply change the URL without a full refresh, and then let React Router handle rendering the correct component. It takes it to prop, which is the path to navigate to. Let's put these concepts into practice by setting up a basic navigation example. We'll create components for home, about, and contact pages. First, let's create our page components. In your SRC folder, you might create new files like home.jsx, about.jsx, and contact.jsx. Home.jsx. Function home. Return h to welcome to the home page, /h2. Export default home, about.jsx. Function about. Return h to about us h2. Export default about. Contact.jsx. Function contact. Return h to contact our team h2. Export default contact. Now, let's modify app.jsx to set up our routing. App.jsx. Import React from React. Import browser router routes route link from React Router DOM. Import our page components. Import home from home. Import about from about. Import contact from contact. Function app. Return. Browser router /1. Wrap your app with browser router. Nav. ul. Link to equals /home/link/li/4. Use link for navigation. Link to equals /about/link/li. Link to equals /contact contact/link/li. ul. Nav. HR / just a separator for clarity. /2. Define your routes inside routes. Routes. /3. Each route specifies a path and the element to render. Route path equals /element equals home / route path equals /about element equals about / route path equals /contact element equals contact / optional. A catch-all route for 404 not found pages. Route path equals element equals h2404 not found h2 routes. Browser router. Export default app. When you run your application, npm run dev, and open it in the browser. The browser router is at the top, managing the application's URL. The nav element contains link components. When you click home, React Router changes the URL to / without a page reload. The routes component looks at the current URL, e.g. It matches the route with path equals / and renders the home component. If you click about, the URL changes to about, and the about component is rendered instead. The routes component ensures only one matching routes element is displayed at a time. The path acts as a wildcard, catching any URLs that don't match the preceding routes, useful for a page not found message. Dynamic routing with parameters. Many applications need routes that aren't static, but depend on some kind of identifier, like a user ID or a product ID. For example, users1, users2, or products Apple Watch. React Router handles this with URL parameters. You define a URL parameter by prefixing a segment of the path with a : e.g., id. You can then access this parameter within the component rendered by that route using the useParams hook. Let's create a user profile component that displays information for a specific user ID. User profile JSX. Import React from React. Import useParams from React Router DOM. Import useParams. Function user profile. Const userid equals useParams. Get URL parameters as an object. This is where you would typically fetch user data based on userid. For now, let's just display it. Return div h3 user profile for ID. User ID /h3. P welcome user ID /p. Imagine fetching data for this user ID here. Div to export default user profile. Now let's add this dynamic route to our app.jsx. App.jsx modified to add user profile. Import React from React. Import browser router routes route link from React Router DOM. Import home from home. Import about from about. Import contact from contact. Import user profile from user profile. New import. Function app. Return. Browser router. Nav. ul. Link to equals /home/link/li. Link to equals /about/link/li. Link to equals /contact/link/li. Link to equals /users/123 user 123 profile link link to a dynamic route. Link to equals /users/456 user 456 profile link ul. Nav. HR. Routes. Route path equals /element equals home /route path equals /about element equals about /route path equals /contact element equals contact // define a dynamic route using userid. Route path equals /user ID element user profile / match users anything. Route path equals element equals h2404 not found h2 routes. Browser router. To export default app. Now, if you navigate to users 123 or users 456, either by clicking the link or typing directly in the address bar, the user profile component will render, and useparams will correctly extract 123 or 456 respectively as the userid. Nested routes. Applications often have complex layouts where certain routes are children of others. For example, a user's dashboard might have nested routes for profile settings, order history, and notifications. React Router supports this with nested routes. To create nested routes, you define a parent route with a path, and inside its element prop, you render child routes. The path prop in a child route is relative to its parent route. The outlet component from React Router DOM acts as a placeholder that tells the parent route component where to render its child route elements. Let's imagine an admin dashboard component with nested, users, and products sections. Admin dashboard JSX. Import React from React. Import link outlet from React Router DOM. Import outlet. Function admin dashboard. Return. Div. h2 admin dashboard h2. Nav. ul. Link to equals users manage users link relative to admin. Link to equals products manage products link relative to admin. ul. Nav. HR. /outlet renders the matched child root component here. Outlet. Div. To export default admin dashboard, and in app.jsx we define the nested structure. App.jsx continued showing nested routes. Import React from React. Import browser router routes route link outlet from React Router DOM. Ensure outlet is imported. Import home from home. Import about from about. Import contact from contact. Import user profile from user profile. Import admin dashboard from admin dashboard. Import admin dashboard. Assume you also have users admin JSX and products admin JSX. Function users admin. Return h3 admin. User management h3. Function products admin, return h3 admin, product management h3. Function app, return, browser router, nav, ul. Link to equals /home/link/li. Link to equals /about/link/li. Link to equals /contact/link/li. Link to equals /users/123 user 123 profile link link to equals /admin dashboard link link to parent route. ul. Nav. HR. Routes. Route path equals /element equals home /route path equals /about element equals about /route path equals /contact element equals contact /route path equals /users /user ID element user profile / parent route for admin dashboard. Route path equals /admin element equals admin dashboard /child routes are defined here. Their paths are relative to admin. Route path equals users element equals users admin / matches admin users. Route path equals products element equals products admin / matches admin products /optional default child route for admin. Route index element equals h to welcome to admin dashboard /h2 route. Route path equals element equals h2404, not found h2 roots. Browser router. To export default app. Now http localhost:5173/admin will show admin dashboard and its default message. http localhost:5173/admin/users will show admin dashboard with users admin rendered in its outlet space. React Router provides other powerful hooks like useNavigate for programmatic navigation outside of link components, and useLocation to get the current URL details. For more complex routing scenarios, refer to the official React Router documentation. By leveraging React Router, you can build sophisticated single-page applications that offer a seamless and intuitive navigation experience, mimicking traditional multi-page websites while retaining the speed and responsiveness of Inspa. This is a crucial step in building real-world React applications, laying the groundwork for how users will move through and interact with your dynamic content. In our next chapter, we'll shift focus to another critical aspect of modern web development: interacting with APIs. Most dynamic web applications aren't useful without external data, and we'll learn how to fetch, display, and manage data from external sources using standard web APIs. Chapter 11. Interacting with APIs, Data Fetching in React. Modern web applications rarely exist in isolation. Most dynamic and useful applications need to interact with external data sources. This data is usually exposed through an application programming interface, API. An API acts as a messenger, delivering your request to a system and then returning the system's response. In web development, we most commonly interact with REST-TFL APIs over HTTP, which use standard HTTP methods, like GET, POST, PUT, DELETE, to perform operations on resources. For example, a weather application fetches data from a weather API, an e-commerce site gets product information from a product API, and a social media app retrieves posts from a user's feed API. Learning how to fetch and display this data in your React application is a fundamental skill. In React, the process of fetching data typically involves these steps. When to fetch data, decide when the data needs to be loaded. This is often when a component initially mounts. Make the API request. Use a JavaScript mechanism to send an HTTP request to the API endpoint. Handle the response. Process the data received from the API, which is usually in JSON format. Manage loading and error states. Inform the user when data is being fetched or if something went wrong. Display the data. Render the fetched data in your component's UI. We'll primarily use the browser's built-in Fetch API, which provides a straightforward way to make network requests. For more complex scenarios, developers often opt for third-party libraries like Axios, but Fetch is excellent for learning the basics. Using Fetch with useEffect and useState. The useEffect hook is the perfect place to initiate data fetching in a React component because it allows us to perform side effects after a component has rendered. And useState is used to store the fetched data, as well as manage the loading and error states. Let's create a simple component that fetches a list of theoretical users from a public API endpoint. A popular mock API service called JSON placeholder is ideal for this. We'll display a loading message while fetching, the user list when successful, and an error message if something goes wrong. User list JSX. Import React, useState, useEffect from React. Function userList. State to store the fetched data. Const users, set users equals useState. State to manage loading status. Const is loading, set is loading equals useState, true. State to manage potential errors. Const error, set error equals useState, null, useEffect, equals. Define an async function inside useEffect to handle fetching. Const fetch users async, equals. Try, 1. Make the API request using fetch. Const response equals await fetch https JSON placeholder.typicode.com/users. Check if the response was successful. If response OK, throw new error, HTTP error. Status response status. 2. Parse the JSON response. Const data equals await response JSON. 3. Update the state with the fetched data. Set users data, catch error. 4. Handle any errors during fetching or parsing. Set error message, finally. 5. Always set loading to false once the request is complete. Set is loading false. Fetch users, call the async function. The empty dependency array runs only once on component mount. Conditional rendering based on state. If is loading, return div loading users, div. If error, return div error, error/div. If not loading and no error, display the users. Return div h2userList h2. ul users map user equals leakey equals user id user dot name user email/lie. ul div export default user list. Now integrate this into your app.jsx. App.jsx. Import React from React. Import userList from userList. Import our new component. Function app. Return div h1 my React application h1. userList, render the userList component. Div export default app. Let's step through the logic of userList.jsx. State initialization, users, an empty array initially which will hold our user objects. Is loading, set to true initially as we are about to start fetching. Error, set to null, indicating no error yet. useEffect for fetching, the effect function containing our fetching logic is defined within useEffect. It's common practice to define an async function inside the effect and then call it immediately. This allows us to use async await syntax, which makes asynchronous code look synchronous and easier to read. Dependency array, this is crucial. An empty array means this effect only runs once after the initial render of the component. This is ideal for initial data fetching that doesn't need to be refetched on every re-render. If you wanted to refetch users when, say, a userid prop changed, you would include user ID in the dependency array. Try ... catch, finally block. This robust structure is used for handling asynchronous operations. Try contains the fetch call and processing of the response. Catch. If an error occurs at any point, e.g., network issues, invalid URL, server error, the catch block executes and we set the error state. Finally, this block always executes, regardless of whether try succeeded or catch caught an error. It's the perfect place to set is loading back to false to indicate that the request has completed. Fetch, URL, this initiates the network request. It returns a promise that resolves to the response object. Response OK. The response object has an OK property. A Boolean that checks if the HTTP status code was in the 200 to 299 range, meaning a successful response. If not, we throw new error to jump to the catch block. Response JSON, this method on the response object parses the response body as JSON. It also returns a promise. Set users data. Once the data is successfully fetched and parsed, we update our user's state with it. Conditional rendering. Before displaying the list, we have if statements to handle our is loading and error states. This provides immediate feedback to the user. First, if is loading displays loading users. If is loading becomes false but error is not null, then if error displays the error message. Finally, if neither is loading is true nor error exists, the list of users is rendered using the map method we learned in Chapter 7. Handling post, PUT, delete requests, fetch options. While get requests, fetching data, are read-only, you'll often need to send data, e.g., forms, or modify resources on a server. The fetch API allows you to specify the HTTP method and send data in the request body using an options object as the second argument to fetch. Let's illustrate a post request, typically used for creating new resources. Example, creating a new user, conceptual, not a full component. Const create new user equals async, user data equals. Try, const response equals await fetch, https, JSON placeholder .typicode.com/users. Method, post, specify the HTTP method. Headers, content type, application/JSON, tell the server we're sending JSON. Body, JSON stringify, user data. Convert JavaScript object to JSON string. If response OK. Throw new error, HTTP error, status, response status. Const new user equals await response JSON. Console log, new user created, new user. You'd typically update your list of users state here. Catch error, console error, error creating user, our message. Example usage. Create new user, name, John Doe, email. johndoe@example.com. Key options for non-GET requests. Method specifies the HTTP method, e.g., post, put, delete, headers, an object containing HTTP headers. Content type. Application/JSON is very common for telling the server to expect JSON in the request body. Body, the data you want to send. For JSON data, you must convert your JavaScript object into a JSON string using JSON stringify. Put requests are similar to post, but are typically used for updating an existing resource, often requiring the resource's ID in the URL, users 123. Delete requests simply use the delete method and usually don't have a request body. Loading states and user experience. Providing visual feedback about data loading is crucial for a good user experience. Without it, users might think the application is frozen or unresponsive. The isLoading state, and sometimes a specific isSending state for post-PUT, is powerful for this. You can display a simple loading text message, a spinner icon, disable buttons to prevent multiple submissions, error handling. Robust applications don't just work when everything goes right. They also gracefully handle when things go wrong. Displaying user-friendly error messages allows clients to understand if there's a network issue, server problem, or invalid input. While our example just shows the error message, in a real application, you might log the error to a monitoring service and display a more generic message like, "Something went wrong. Please try again later." Interacting with APIs is an indispensable part of building dynamic web applications. By mastering Fetch along with useState and useEffect, you can seamlessly integrate external data into your React applications, making them truly powerful and interactive. With the knowledge of components, state, effects, routing, and data fetching under your belt, you now have the fundamental building blocks to create almost any type of web application. In our final chapter, we'll bring all these concepts together by working through a practical, comprehensive example, guiding you through the process of building a complete, small-scale React application from start to finish. This will be your real-world test, solidifying everything you've learned. Chapter 12. Bringing it all together, building a full React application. Congratulations! You've journeyed through the core concepts of React, from understanding its fundamental principles to mastering hooks, routing, and data fetching. Now it's time to solidify all that knowledge by building a practical application that integrates everything we've learned. This hands-on project will serve as a capstone, demonstrating how all the individual pieces fit together in a real-world scenario. For this final chapter, we'll build a simplified task manager application. This app will allow users to view a list of tasks, mark them as complete, and add new tasks. It will utilize components, state, effects, conditional rendering, list rendering, and API interaction. We'll assume you have an active React project set up as per Chapter 2. If not, quickly create one using npm create vite at latest. Project setup and overview. Our task manager will feature a main page displaying a list of tasks, the ability to fetch tasks from an external API. We'll simulate this with a local JSON file or simple in-memory data that persists across refreshes for demonstration. Or we can use the JSON placeholder API again, a form to add new tasks, the ability to toggle a task's completion status, basic styling. We'll organize our files in the SRC folder. Let's imagine our API data structure for tasks. Each task will be an object with id, a unique identifier, e.g. a number. Text, the description of the task, e.g. buy groceries. Completed, a Boolean indicating if the task is done, true or false. For simplicity, instead of setting up a full backend, we'll use a simple in-memory array for our tasks to simulate API interactions. This allows us to focus entirely on the React concepts. Step 1. Initial app.jsx and basic layout. Let's start by clearing out some of the boilerplate in app.jsx and setting up a basic structure. src/app.jsx. Import React, useState, useEffect from React. Import /app.css for basic styling later. Function app. Const tasks set tasks equals useState, state to hold our tasks. Simulate fetching tasks on component mount. useEffect equals. In a real app, this would be an API call. Const initial tasks equals id 1 text, learn React hooks completed, true. Id 2 text, build a task manager completed, false. Id 3 text, read React unlocked book completed, false. Set tasks initial tasks. Run once on mount. Return div class name equals app container. h1 my task manager h1 / task list component goes here. Add new task form goes here. Div export default app. For now, app CSS can be empty or have simple styling for app container like max width 800px, margin 0 auto, padding 20px, font family sans serif. Step 2. Creating the task list component. This component will be responsible for displaying all our tasks. It will receive a tasks prop and also a function prop to handle toggling completion status. Create src/component/task list JSX. src/component/task list JSX. Import React from React. Import task item from task item. We'll create this next. Function task list, tasks on toggle complete. If tasks length equals 0, return p no tasks yet, add some above p. Return div class name equals task list. Tasks map task equals task item, key equals task ID. Task equals task. On toggle complete equals on toggle complete. Div export default task list. We receive tasks and on toggle complete via props, chapter 4. We use conditional rendering, chapter 7, to show a no tasks yet. Message if the tasks array is empty. We use the map method for list rendering, chapter 7, iterating over each task and rendering a task item component for it. Crucially, we pass the key prop here, using taskid, which is unique. Step 3. Creating the task item component. This component will display a single task, its text, and a checkbox to mark it complete. Create src/components/task item JSX. src/components/task item JSX. Import React from React. Import /task item CSS for styling completed tasks. Function task item, task on toggle complete. Return div class name equals task item, task.completed. Completed. Input type equals checkbox. Checked equals task.completed. Controlled component chapter 8. On change equals on toggle complete task ID. Event handling chapter 8. Span style equals text decoration. Task.completed line through none. Task text span div export default task item. It receives task and on toggle complete as props. The checkbox is a controlled component, chapter 8. Its checked attribute is bound to task.completed, and its on-change event triggers on toggle complete. We apply a completed CSS class using a template literal and conditional logic task.completed. Completed, when the task is done, allowing us to style it, e.g. grayed out. We use an inline style, chapter 3, to add line-through text decoration for completed tasks. Now, let's create src/components/task item CSS. /src/components/task item CSS. Task item, display, flex, align items, center padding 10px, border bottom 1px solid E. Task item last child, border bottom, none. Task item input type equals checkbox. Margin right 10px transform, scale 1.2. Task item span, flex grow 1. Allows text to take up remaining space. /style for completed tasks. .task-item.completed span. Color 888. Step 4. Creating the add task form component. This component will provide an input field and a button to add new tasks. Create src/components/add task form JSX. src/components/add task form JSX. Import React useState from React. Function add task form on add task. Const new task text, set new task text equals useState. State for input field, chapter 5. Event handler for input field change, chapter 8. Const handle change equals, e equals. Set new task text, e target value. Event handler for form submission, chapter 8. Const handle submit equals, e equals. E prevent default, prevent page reload. If new task text trim, ensure text is not empty. On add task new task text, Call parent function to add task. Set new task text. Clear input field after adding. Return. Form on submit handle submit. Class name equals add task form. Input. Type equals text. Placeholder equals add a new task. Value equals new task text. Controlled component. On change equals handle chain. Slash button type equals submit add task button. Form. Export default add task form. useState manages the input field's value, making it a controlled component. OnChange updates the state, and handle submit is called on form submission. ePrevent default is used to stop the browser's default form submission behavior, Chapter 8. The onAddTask prop is a function passed from the parent component, which will handle the actual logic of adding the task to the main task state. Step 5. Connecting components in app.jsx and adding logic. Now, let's put our new components into app.jsx and add the functions to manage tasks. Update src/app.jsx. src/app.jsx. Import React. useState useEffect from React. Import task list from components task list. Import task list. Import add task form from components add task form. Import a task form. Import/appcss for basic styling later. Function app. Const tasks set tasks equals useState. State to hold our tasks. Const next ID. Set next ID equals useState 4. Simple way to generate unique IDs. Simulate fetching tasks on component mount. useEffect equals. In a real app, this would be an API call. Const initial tasks equals. id. 1 text, learn React hooks completed, true. id. 2 text, build a task manager completed, false. id. 3 text, read React unlocked book completed, false. Set tasks initial tasks. Run once on mount. Function to add a new task. Const handle add task equals text equals. Const new task. id. Nexted. Text. Completed, false. Set tasks prev tasks equals prev tasks new task. Update state immutably, Chapter 5. Set next ID, prev ID equals previd +1. Increment next ID. Function to toggle task completion status. Const handle toggle complete equals id equals. Set tasks prev tasks equals prev tasks map. Task equals taskid equals id. Task completed. Task.completed. Task immutable update. A return. Div class name equals app container. h1 my task manager h1. Add task form on add task equals handle add task. / pass handler to form. Task list tasks equals tasks. On toggle complete equals handle toggle complete. / pass data and handler. Div. Export default app. We've added nexted state to generate unique IDs for new tasks. Handle add task. This function creates a new task object, and then importantly, updates the task state using the functional update form of set tasks. It uses the spread syntax, prev tasks, to create a new array, ensuring immutability, Chapter 5. Handle toggle complete. This function updates the completed status of a task. It also uses map to create a new array with the modified task, maintaining immutability. Finally, we render add task form and task list, passing them the necessary props to communicate and handle data flow. Step 6. Basic styling. Let's add some simple global styles to src/appcss and src/components/add task form CSS to make our application look presentable. src/appcss/src/appcss. Body. Margin 0, padding 0, background color F4. Font family Arial sans serif, color 333. App container. Max width 600 px. Margin 40 px auto, background color FFF, padding 30 px, border radius 8 px, box shadow 04 px, 12 px, RGBA 0000.1. H1. Text align. Center color 2C3E50. Margin bottom 30 px. Task list. Margin top 20 px. Border 1 px solid DDD. Border radius 4 px. src/components/add task form CSS. /src/components/add task form CSS. Add task form. Display flex gap 10 px. Margin bottom 20 px. Add task form input type equals text. Flex grow 1 padding 10px 15px. Border 1px solid DDD. Border radius 4px. Font size 1 rem. Add task form button. Padding 10px 20px. Background color 28A745. Color white. Border none. Border radius 4px. Cursor pointer. Font size 1 rem. Transition. Background color 0.2's ease. Add task form button. Hover. Background color 218,838. Remember to import components/add task form CSS at the top of your add task form JSX file. Running the application. Save all your files. If your development server isn't running, navigate to your project directory in the terminal and execute npm run dev. Open your browser to the local address provided, e.g., http localhost:5173/. You should now see your fully functional Task Manager application. You can check off tasks, and they'll get a line-through and updated color. You can type new tasks into the input field and click Add Task to see them appear dynamically. The initial tasks are loaded when the application starts. What we've accomplished. This simple Task Manager demonstrates how interconnected and powerful React's core concepts are: components and props. We broke the UI into small, reusable pieces: app, task list, task item, add task form, and pass data down using props. State, useState. The tasks array and new task text are managed as state, allowing dynamic updates to the UI. Effects, useEffect. We used useEffect to simulate fetching initial tasks when the application loads. In a real application, this is where you'd make your fetch Chapter 11 calls to a remote API. Conditional rendering. Displaying no tasks yet when the list is empty. List rendering, dynamically generating task item components from the tasks array. Event handling and forms, responding to checkbox clicks and form submissions, and using controlled components for input fields. Immutability. Crucially, we always updated our state, especially arrays, by creating new arrays or objects, preventing subtle bugs and ensuring React re-renders correctly. This project is a solid foundation. From here, you could extend it by implementing actual API calls for adding, updating, and deleting tasks. Adding filtering options, e.g., show only completed tasks, show only active tasks. Integrating React Router to have different views, like an About page or a detailed task view page. Adding user authentication features. Improving the styling and user experience. Your journey forward. You've now unlocked React. You have a comprehensive understanding of its core principles and practical skills to start building your own dynamic web applications. The key to truly mastering React lies in continuing to build, experiment, and explore. Practice. The more you build, the more intuitive React will become. Start small, then gradually increase the complexity of your projects. Read the official docs. The React documentation is excellent and constantly updated. Refer to it often. Explore. Look into additional libraries and tools that complement React, such as state management solutions, like Redux or useState for very large apps, though Context API goes a long way, styling libraries, or testing frameworks. Community. Engage with the React community. There are vast resources, tutorials, and forums available. React is a powerful and versatile library. By understanding the concepts in this book, you are well equipped to navigate the exciting world of modern web development and create amazing user experiences. Happy coding!